Hello, so this video is a quick revision about optics, specifically geometrical optics. So we have mainly the three branch of optics that we generally study. First is geometrical optics. It deals about rays, mirrors, lenses. Then we have physical optics, mostly wave nature, interference, diffraction, and polarization. Then we have visual optics, that is eye and vision, which is quite less studied in competitive exams. Now, if we broadly divide the properties of geometrical optics, we have rectilinear propagation. Basically, what it means is in a homogeneous medium, light travels in straight line. Okay. Now, let's discuss about law of reflection. Now, what law of reflection says is that the incident ray, reflected ray, and normal all lie in the same plane, and the angle of incidence will also be equal to angle of reflection. This is very important. Now, what law of diffraction says is that it's quite similar to the law of reflection, but that in refraction we have two mediums. So the light should enter from a medium and then it should exit in another medium. Then it falls under refraction. Now, this is the famous Snell's law, where you have the refractive index of the first medium multiplied by sine I equal to refractive index times sine R. Now there are various numerical related to this equation, where n is the refractive index, I is the angle of incidence, R is the angle of refraction, and V is the speed of light in the medium. Now, few important note: ray bends towards normal in denser medium, ray bends away from the normal in rarer medium. Now, another important note is that the refraction law apply for a given pair of media and wavelength. So when you are studying refraction, when there is medium 1 and on the other side we have medium 2, this is where the law of refraction applies. Now let's move on to some other properties. First is dispersion or wavelength dependence of refractive index. Now, here it says n of violet is greater than n of red. What it means is, let's say you have a white light that is coming in, okay? Now you will see that if it is red light, it will be bent less. If it is violet light, it will be bent more. So, for normal dispersion, n increases as wavelength decreases. This you have to remember while solving the problems. Principle of independence of rays. Now, when there are two rays and it is intersecting, rays cross, paths remain independent. So basically it will just move on and this will also move on. It will not interfere, unlike electric field. Principle of reversibility. So what it means is, let's say you shine light from P and it reflects and then moves to Q. Then if you shine light from Q, it will again reflect and it will definitely go to point P. This is called principle of reversibility, that if you reverse the path, it will follow the same path. Now, the next concept is object and image. Now, object is equal to source of incident light. Whenever you draw any object, you have to draw two lines, basically light emitting from the object. Image is where point where reflected and refracted ray meet or appear to meet virtually. Now, another concept is conjugate foci. Conjugate foci, if an object is at one point, image forms at another point. So this is the principle of conjugate foci. Now the key idea is that light travel in straight line in a uniform medium. Angle of incidence is equal to angle of refraction. And you have Snell's law, that is also very important. And another important point is that reversibility and independence of light. So this is the very condensed revision of optics. Now, if you're interested about the mock test and concept practice test, check the description or the QR code in the screen. Thank you. And if you have any queries, definitely feel free to mail.